Let's move to the next question. In this question, we are given sum of n, 2n, 3n terms of an APR S1, S2, S3. We have to prove S3 is equal to 3 times of S2 minus S1. Let's work out the problem. According to the question, sum of n terms of an AP is S1. If we take A is the first term and D is the common difference, then the sum of n terms of an AP is n upon 2 times 2A plus n minus 1 times D. Similarly, sum of 2n terms of an AP is S2. To get the value of S2, in place of n, we substitute 2n so that we get sum of 2n terms, that is 2n upon 2 times 2a plus 2n minus 1 times d. It is because we have to find out sum of 2n terms. Similarly, sum of 3n terms of an AP is S3. S3 is obtained by placing n with 3n. That implies 3n upon 2 times 2a plus 3n minus 1 times d. It is because we have to find sum of 3n terms. To prove this relation, S3 is 3 times of S2 minus S1. We will take right hand side and we show that right hand side is equal to left hand side. To prove this, let us consider difference between S2 and S1, that is S2 minus S1. Let us substitute these values from the above results. We have S2 is 2n upon 2 times 2a plus 2n minus 1 times d, and S1 is n upon 2 times 2a plus n minus 1 times d. Let us simplify this. We take n upon 2 common from both these terms. Then we remain with 2 times this term. Let us simplify it. We have 2a, and then let us distribute this d inside the bracket. That implies 2nd minus d. Similarly, from this term we have taken n upon 2 common, so we remain with negative sign. We must be careful when we have negative sign. We write it as it is, and then we have this term, that is 2a plus n minus 1 times d. If we distribute n inside the bracket, then we have nd minus d. Let us simplify it. N upon 2 times, here we have 2, so we distribute 2 inside the bracket. It is 4 times a plus 4nd minus 2d. It is because we are multiplying whole expression with 2. And then we distribute negative sign inside the bracket. We have negative 2a, and minus of plus nd is minus nd. Similarly, minus of minus d is plus d. Let us simplify this expression. We have n upon 2 times. Inside the bracket, we have 4a minus 2a, which is equal to 2a. Similarly, we have 4nd minus nd. They are like terms. 4nd minus nd is 3 times nd. And then we have negative 2d and plus d, which is equal to minus d. Let us simplify it further. Then we have n upon 2 times. We have 2a, and then we have plus 3nd minus d. If we take d common, then we have 2a plus 3n minus 1 times d. What is this value? It is the difference between S2 minus S1. What we have to prove? We have to prove S3 is equal to 3 times of S2 minus S1. We already have S2 minus S1. If we multiply this equation with 3, we get 3 times of S2 minus S1, which implies 3n upon 2 times 2a plus 3n minus 1 times d. It is exactly equals to S3. What we have S3? S3 is 3n upon 2 times 2a plus 3n minus 1 times d, which is equal to S3. On rearranging, we get S3 is equal to 3 times of S2 minus S1. Hence, the given relation is proved.